A very good morning everyone. Myself Vinita, working as lecturer in Government Polytechnic, Mirle. I like to welcome you all for the first session on formation of steam. Before going for the actual topic, let us try to understand what you mean by applied thermal engineering. As the name itself indicates, thermal, which deals with thermal energy. Therefore, I can define the applied thermal engineering as a subject which deals with the relationship between heat, work and its systems and their applications. So, in simple words, it can be defined as the conversion of thermal energy into useful mechanical work and their applications. So this applied thermal engineering is one of the subjects for 5th sem diploma mechanical engineering students. Let's begin with the first unit of ATE, that is formation of steam. These are the content of my presentation, which includes the introduction part and then which are the various processes that are involved in the steam formation and their definitions and what are the advantages of superheated steam, and lastly we are going to cover the TH diagram. These are the contents that will be covered in this particular session. Let's begin with the first one, that is formation of steam. It's very important for everyone to understand what you mean by steam. So the gaseous or vapor form of water is defined as steam. As we all know that the water exists in three forms: solid, liquid and gaseous form. So ice is an example for solid state, water is example for liquid state, and steam is the best example for the gaseous state. Therefore, we are going to define steam as what? The gaseous or vapor form of water can be termed as steam. Then how do we going to produce this steam? This steam is produced either by boiling or evaporating the water in a closed chamber, which is called as steam generator or boilers, by keeping the pressure constant. So I'll repeat once again. We're going to produce the steam by heating or evaporating the water in a closed chamber called steam generator or boilers at constant pressure. Then what is the necessity of learning this formation of steam? Why do we need to learn this? This is a question that arises in your mind. For that I'll tell you, this, as already I told you, steam is obtained from water. We all know that water is freely available in nature and it's very abundant. And steam has got a very good quality, like it has got an ability to absorb large quantity of heat. So this characteristics makes the steam to be used as the working medium in various thermodynamic systems. Now we understood what is the definition of a steam. Then how do we going to obtain the steam? So I told you that we are going to obtain the steam by boiling it at constant pressure. That is not sufficient. So now let us try to understand what are the various processes that are involved in the formation of the steam. For that, let us consider 1 kg of water at 0 degree Celsius that we have taken in a piston cylinder arrangement. So this is a cylinder what you have, and this is a piston. So we have taken 1 kg of water at 0 degree Celsius in a cylinder piston arrangement. Above the piston you can see a weight. This weight is kept so that we will get a constant pressure. The pressure is at constant. For this purpose, the initial condition is represented at the point A in the TH diagram, that is temperature enthalpy diagram. So the initial condition of the water, which is at 0 degree Celsius, is represented by point A in TH diagram, that is shown in the figure A. So what we have done? We have taken 1 kg of water at 0 degree Celsius. When we start heating this water, there will be a rise in temperature of water. So the temperature of the water start increasing till it reaches the point called the boiling point. So there will be a increase in temperature of the water till it reaches a point called the boiling point or a boiling temperature. So from today, instead of saying a boiling temperature, we'll give a different name, the technical name, that is saturation temperature. So the saturation temperature is a temperature where the water starts boiling. So this is called as T saturation, that is represented by T saturation. So during this process, that is A to B, what is happening? We are heating the water at 0 degree Celsius to its boiling point. So the heat absorbed by during this process is represented by what? The sensible heat. So the amount of heat required to raise the water from 0 degree Celsius to the boiling point is called as what? Sensible heat, which is represented by HF. As the H indicates heat. What we are doing? We are giving heat to the water. The system is water. We are giving heat. So it is represented by what? F. Why F? Because still water is in the liquid form. Hence it is denoted by HF. So during this process A to B, as the temperature increases, I told you there will be a rise in temperature. You can see in the diagram itself. As the temperature increases, there will be an increase in the volume. So which is shown in the figure 2. So it has reached the boiling point. So if we come for the next process, that is B to C. So in the process B to C, you can see the temperature has remained constant at T saturation. So if we further continue the heating of the water, the temperature remains constant, but there will be a change of phase from liquid to the vapor. What is happening? The phase of the water will change from liquid to the vapor. That is, it is a process where the vaporization has been started, but the temperature remains constant. In this particular process, the temperature as well as the pressure will remain constant, but there will be a change of phase from B to C. That is, I can say the water is converting into steam. Water at boiling point is now converting into dry steam. There is, at this particular point, the steam what we are going to obtain will be completely dry, but the steam at this point is completely wet. That is, it consists completely of water particles. So the process of conversion of water, boiling water into the dry steam is represented by what? BC, the straight line BC. So the point at point B, as I told you, we have a wet steam, that is, which contains water particles. So this water particle, you can see we have distinguished between two space. One is water and one is wet steam. So as we know that water has a high density, that hence it will settle at the bottom of the cylinder. The steam which has been formed will start evaporated. So during this particular process, there will be an increase in volume, but the temperature remains constant. Hence we call that it's not a perfect gas, hence it does not obey any gas laws or Charles law. Okay, so next, this process BC, the amount of heat absorbed during this process is termed as what? The latent heat. So then what do you mean by latent heat? Why we are calling it as a latent heat? Before that we call it as sensible heat because we are able to sense the increase in temperature. But if we come here, it is latent heat. So latent heat, or it is called as hidden heat. It is called as hidden heat because the temperature, there is no rise in temperature. Even though we are supplying the heat, it is not sensed by the thermometer. The temperature remains constant, but there will be absorption of heat which is useful to convert the steam, wet steam, into a dry steam. So this latent heat is utilized to convert the wet steam into a dry steam. Okay, hence it is called as latent heat or hidden heat. We are not able to sense it, hence it is called as a latent heat. It is represented by HFG. Already I told you H is for what? Heat, F is for fluid, and G is for gas. This indication itself indicates that the process B to C is a process where we can see both fluid as well as gaseous state. So it's a mixture. The steam will be in the form mixture of water, and the dry steam will be present during this process. So at the end of this particular process, we will obtain what? The dry saturated steam will be obtained. That is, all the wet steam will be converted into a dry saturated steam at this particular point C. So which is represented by the figure 4. Let us go for the next slide. So, so the point C, at particular point C, what we have? We can see the condition of the steam is dry saturated. That is, the dry steam is present inside this, but in the cylinder arrangement. So in this particular cylinder arrangement, as the temperature increases, see the temperature has remained constant at this particular point. It already has completely converted into gaseous form at this point. Hence, see what they have given, converts remaining wet steam into dry saturated steam at same saturation temperature. This dry saturated steam, even this obeys Boyle's law because it has already become the dry saturated. As the temperature increases, see from point C there will be a rise in temperature. So as the temperature increases, there will be an increase in the volume. Okay. So if we further continue heating the process from C to D, what happens? Again there will be a rise in temperature. In the process B to C, there was a constant pressure and constant temperature. There was no rise in the temperature. If we heat beyond point B, there will be a rise in temperature. Therefore, as the temperature rises, again the specific volume of the steam will increases. This particular steam is referred as superheated steam. So the steam which is obtained above the saturation temperature, you can see it's above the saturation temperature, is called as what? Superheated steam. So this amount of heat required to raise the steam above the saturation temperature is called as what? Superheated steam, or heat of superheat, or sensible superheat. We can, again this rise in temperature can be sensed. We can sense it. Hence it is called as a heat of superheat, which is represented by H super. That is superheated temperature, to indicate that. So there will be a rise in temperature. For this particular reason, there is no restriction. You can raise the superheated temperature anywhere you want, depending upon the application. This is the process that are involved in the TH diagram. So let us recall what we have studied, which are the various processes that are involved in the formation of steam. First, we had what we had taken. We had taken water. We had taken 1 kg of water at 0 degrees Celsius. That is the one point. What we have done? We have taken 1 kg of water at 0 degrees Celsius, which is represented by point A in the TH diagram. So this condition is indicated by figure 1. As we start heating the water, the temperature of the water rises till it reaches the point B. So this is indicated by the figure 2. So as the temperature increases, there will be an increase in the volume, specific volume. Till where it is going to be heated? Till it reaches the point called as saturation point. This is the temperature you need to remember throughout the semester, that is T saturation temperature. So the boiling point of the water is called as T saturation. So which is that? T saturation. So the process AB. So the amount of heat during this process is called as what? The sensible heat. Remember that? Sensible heat, which is represented as HF. So the process B is utilized to convert the liquid form into the what? The gaseous form. So which is represented by the process B to C. During this process we will represent two diagrams, one to indicate the wet steam and another to indicate the dry steam, which is called as latent heat of evaporization, because this is a process where the evaporation process is going to be taken place. Hence this is represented by what? Point BC, the process BC. So if we further continue the heating process, there will be a rise of temperature beyond the saturation temperature, which is called as superheated temperature. This is called as, and the amount of heat is required is called as superheat. Okay, did you got the point? So in the formation of steam, if they ask in the examination to explain the formation of steam with the help of TH diagram, then you have to write this. So which are the points do you need to remember? One is, you are taking 1 kg of water at 0 degrees Celsius. Secondly, we are heating the water till the boiling point, which is represented at T saturation. During this process there will be an increase in volume and there will be an increase in the temperature. And thirdly, what we are doing, there is a change of phase from B to C. This change of phase from B to C will represent by two diagrams. One is for the wet steam and another is for the dry steam. Wet steam, the point B. Why point? Two diagrams? Because here the temperature remains constant, but there will be only rise in the volume, specific volume. But here the both dry saturated steam and superheated steam, they both obey the gas law. Hence they are called as a perfect gas. Okay, hence it is represented by two diagrams. Even the process is same, the process is conversion of liquid to the vapor state, but the properties of behavior of the water and the steam is completely different. Hence it is represented by two lines. So let us try to understand which are the different forms of steam. As I already told you that steam will be available in three states or in three forms. One is the wet steam, the dry steam and superheated steam. So in the previous slides we learned the formation of steam. So what we did, we heated the water from 0 degrees Celsius to the boiling point. The further addition of heat made the conversion of wet steam into the dry steam or liquid state into the gaseous state. That is what we told you. So this particular region, the steam which is present at this particular region is called as what? Wet steam. So how can I define it then? The steam that contains water particles in suspension can be defined as what? Wet steam. So the steam present in the region B to C. So anywhere in this particular region, it can be here or here, here or somewhere anywhere in the region B to C, the steam is referred as what? The wet steam. So wet steam can be defined as what? The steam which contains water particle in suspension can be defined as a wet steam. Then what do you mean by dry steam? The steam that is present at point C. You can call this as a dry steam or dry saturated steam. If they ask you to explain dry saturated steam, it's one and the same. The dry steam and dry saturated steam is same because it's in the saturation condition. So the steam that is obtained at point C can be defined as dry steam. So the name itself is indicating that is it is dry. Dry means it does not contain any water particles. The steam which does not contain any water particles and which obeys the Charles law is called as what? The dry steam. Understood? So now let us go for the third state or third form of the steam, which is a superheated steam. So the steam that is present in the region C to D is called as superheated steam. The steam which is formed at a temperature higher than the saturation temperature. I'll repeat once again. The steam which is formed at a temperature higher than the saturation temperature can be defined as what? Superheated steam. So let us recall what we had learnt in this particular slide. There are three forms of steam. One is a dry steam, wet steam and a superheated steam. So wet steam is the one which presents in the region anywhere in the process B to C, in the region B to C. That means we can define wet steam as the steam that contains water particles in suspension can be defined as wet steam. So the second one is dry steam or dry saturated steam. The steam that does not contain any water particles is called as dry saturated steam. Then the superheated steam, the steam which is formed at a temperature higher than the saturation temperature can be termed as superheated steam. So now let us try to understand what are the advantages of this superheated steam. In the initial slides itself I have mentioned that the steam has got a capacity to absorb high heat content. So it has got an ability to absorb large heat or huge heat. So which helps to do work. So the high capacity of work can be obtained by using this superheated steam. So what will happen? This will result in economy in the steam consumption, that is the amount of steam consumed will be comparatively less, because in a small amount of steam we can produce large number of heat, large number of work can be done, large amount of work can be produced. Hence the efficiency of the steam plant will be increased. Okay, so the steam has gotten high heat content, ability to absorb high heat, so which helps us to do the more work, which will yield in increase in the efficiency. So that, as already we know that the superheated steam has got a temperature higher than the saturation temperature. So obviously it yields high thermal efficiency. So this superheated steam it can be cooled during the expansion of the engine cylinder. During this, so Lou has to cause the condensation of the cylinder. So the condensation of this steam will be comparatively easy, which yields in the direct heat loss. So the condensation process of the superheated steam is comparatively easier for the other steam, maybe a saturated steam or a wet steam. So that is the advantages of the superheated steam. So, and one more thing, this superheated steam is obtained from the waste furnace gases. So once the dry steam is obtained, the further heating of the steam will be carried out by using the pipe, the furnace gases. The outlet of the furnace gases will be connected to the boilers. So this waste gases will be used to produce the superheated steam. So there is no necessity for any special equipments to produce superheated steam. So hence we can save the money. These are the advantages of the superheated steam. So advantages of superheated steam, there are so many advantages. We can say that we know that superheated steam is completely in the vapor form, hence the density of the vapor will be lesser than the liquid, hence it will be lighter in weight and it can be easily handled. Okay, so which are the points we need to remember in this slide? It has got an ability to absorb high heat, therefore it can do more work, therefore the steam consumption will be less. So only in this point you can write 3 points. Okay, so since the temperature of the superheated steam is higher than the saturation temperature, it yields high thermal efficiency, and condensation process for the superheated steam is very easier compared to the other forms of steams, and this superheated steam is obtained from waste furnace gases. Let's go for the next one. Again, it's a TH diagram for the formation of steam at constant pressure. So here already we have studied this representation, that is temperature enthalpy diagram or a graph. What we have done? We have plotted temperature versus the enthalpy. The graph is plotted versus where? The temperature versus the enthalpy. So it's a repetition, it will be a repetition. What we did? We have taken water at 0 degrees Celsius and we have started heating the water from point A to point B. This region is called as what? Sensible heat, that is SH. So during this process A to B, there will be an increase in temperature. As the temperature wait till it reaches the point, the boiling point of the water, or what I told you, instead of saying the boiling point, what we need to say is T saturation. We have to say it as what? The T saturation temperature. Till it reaches the saturation temperature, there will be a rise in temperature of the water till it reaches a saturation temperature. So if we further continue heating, there will be a change of phases from during the process B to C. There will be a change in process from water to C. I can say water to steam. There will be change of water to steam till point B to C. Again, if you further continue heating, that is from C to D, there will be a superheated region. With the superheated region will be obtained. So I can distinguish this graph into three regions. Here we'll have only a liquid portion, liquid will be there. This is a region where both the water and steam will be present. This is a region where only the superheated steam will be obtained. Okay, understood? So we have three regions in the TH diagram. One is the liquid region, I can say liquid region, and one is the water steam region, and third one is what? Superheated region. So this is for particular pressure. How we are carrying out the process? By keeping the pressure constant. So let us say, I'll say for the pressure P1, I have taken pressure, let us consider this pressure as P as 1 bar. for 1 bar pressure, the boiling point or saturation temperature is 100 degrees Celsius. So, let us consider we have taken 1 kg of water at 0 degrees Celsius. We have started heating the water till it reaches the saturation temperature, that is 100 degrees Celsius. Once it reaches the saturation temperature, there will be a change of phase from liquid to the gaseous state till all the water suspension is converted into the dry steam. So during this process, we will get a dry saturated steam. If we further continue heating, the steam what is obtained will be a superheated steam. This is for what? For 1 bar pressure, that is for 1 atmospheric pressure. I am talking about for 1 atmospheric pressure, the boiling point is what? I said 100 degrees Celsius. Okay. So let us consider, let us increase the pressure, say P1. So we have taken the pressure P1. If I take the pressure P1, you can observe clearly that this is called a sensible heat, right? So the sensible heat has been increased. What has happened? There is an increase in sensible heat. That means you can see the dotted line here, and if I draw a line here, there is a difference between here. That means, and I can plot here also, this was the temperature for the pressure P1, and this is the temperature, saturation temperature for pressure P1. So there is an increase in temperature. So I can tell you that as the pressure increases, the saturation temperature also increases. That is the indication in this particular diagram. As the temperature increases, even the pressure increases, there will be an increase in the sensible heat. So which is represented by the point AE. There is an increase in the sensible heat. Okay. So, but clearly you can observe that. So the vaporization region, that is, this is a region where, as I already told, BC, which is a region where the steam is water is going to convert it into vapor form. So this particular process has been reduced. You can see clearly this process has been reduced. So there will be a reduction in the latent heat of vaporization. So in the sensible heat, there was an increase in the sensible heat. As the pressure increases, there was an increase in the temperature, but the latent heat of vaporization has been reduced. So now let us consider pressure P2. I can say P1 is 10 bar, I can take it 10 bar, anything that you want. So let us consider we are heating the water at pressure P2. Take it as 100 bar. Okay. So if I observe at pressure 100 bar, what's happening? The saturation temperature of the water is much more increased. It is increased. See, this was the initial saturation temperature. In the P1, this was the saturation temperature. For pressure P2, this line is the saturation temperature. Once again, it's proving that as the pressure increases, there will be an increase in the saturation temperature and increase in the sensible heat. But there will be a reduction in the latent heat of vaporization. Okay. So if we continue this process, we are going to reach a point where the latent heat of vaporization will be a 0. So if we increase the pressure, so we are going to reach a point. So if we further keep on adding if we keep on increasing the pressure, it will reach a point where the latent heat of vaporization will become 0. That point, so where the liquid line and the dry steam will meet, is called as the critical point. Understood? So the region, so there will be no conversion. So directly the liquid will be converted into a dry steam. So it's a critical point. So Critical point means where the latent heat of vaporization is 0. Remember that the latent heat of vaporization is 0. That particular point N is called as what? Superheated steam. So again you can see here the point N where the liquid and dry steam lines meet. The way the liquid line and the dry saturated steam line meets is called as what? Is called as the critical point. The temperature at the critical point is called as critical temperature, and the temperature at the pressure at the critical point is called as critical pressure. So the critical pressure of the water is 227.6 bar and temperature is 375 degrees Celsius. So how can we define it? So let us recall the process. As we increase the pressure, as the pressure is increased, there will be increase in the temperature, saturation temperature, and there will be increase in the sensible heat, but there will be a reduction in the latent heat of evaporization. It will reach a point where the latent heat of evaporization will become 0. That particular point is referred as the critical point. So the critical point is the one where the liquid line and a dry saturation line meets. So the liquid and dry saturation line meets. That particular point is called as the critical point. So the pressure at that particular critical point N is called as critical pressure, and it is 227.6 bars. And temperature, particular temperature where the water is directly going to convert into dry saturated steam, there will be no change of phase. Directly the water is going to be converted into dry steam. That particular temperature is called as critical temperature, which is 375 degrees Celsius. So beyond this we cannot heat the water. Beyond this particular pressure we can't heat the water. This is the ultimate or last point where we can heat it. Hence it is called as a critical point. Okay, this was about the TH diagram. Let us recall what we have studied today. We studied about the definition of a steam, then about the formation of steam, which are the various steps that are involved in the formation of the steam, and few definitions like a sensible heat, latent heat, and the superheat. And what happens for the change of volume during this particular process, how the volume varies with respect to the temperature, that we understood by this particular formation of steam process, and which are the three different states of steam, and how we can represent that in a TH diagram that we studied. And then we studied about the advantages of a superheated steam, what are the different various advantages that we come across. And lastly we studied about the TH diagram and what is about the critical point, and then the critical point, and what is critical temperature and critical pressure, and what are the values. So dear students, so in the next session I want you people to tell me the value of critical pressure. Hence I have not mentioned this slide. So you have to tell me what is the value of critical temperature and critical pressure, but I have mentioned it, I have told it twice. You have to tell me that, and you have to tell me that you have to write the TH diagram and you have to upload the same to the, you have to write it in a sheet of paper. Okay, that will be your assignment for today's session. You have to collect the other advantages of superheated steam. So today's assignment will be the two things. One is you people have to mention the critical temperature and critical pressure of the water, and have mentioned 4 advantages of a superheated steam. You have to collect the other advantages of a superheated steam, and you have to distinguish the difference between the superheated steam and the wet steam. Okay, this was the assignment what I have given. That's all for this session. Thank you very much.